All right. Today, obviously, I'm not here. We're going to do the lab that we talked about a little bit yesterday called How Dry Am I? So if you'll go ahead and find that, I believe that is on page number 6. Let me check real fast. Yep, that is on page number 6. So if you would take out your lab books and turn there. We'll be in the lab here in a second. I'll just explain a little bit what we're going to do. But first, in this exercise, if you'll read the directions with me, you will put water in cans labeled products and reactants. So I'll have those just right over there in the lab. If you'll look real quick, that didn't work. So I have those just right there. 2 cans labeled products and reactants. And you can see those. There's a huge pile of those cans right there on that cart. And then the beakers will be farther over on the table when you need those. All right, so that's all you'll need. Well, and a couple of rulers that we'll put out right there by those as well. So let's come back up here. Okay, so in this exercise, you'll put the water in those cans. You will use the appropriate size beakers to transfer water back and forth until an equilibrium is reached. And please underline this in your notes. An equilibrium is reached when there is no change in the height of water in either can for at least 5 consecutive water transfers. So what that's saying is you're going to have your products can and your reactants can. An equilibrium will be established when the height isn't changing. That does not mean that the water level is equal in both. It just means when you pour this way and you pour that way, that the height isn't changing. If the height isn't changing, then our forward and reverse rates are the same, and that's what we want as far as equilibrium is concerned. All right, some more of the instructions. All right, so we're underlining that in our instructions. Then it says record the height of, that's been a misprint for 15 years, of water in each can in the data tables. So the data tables would be these. So what you'll have here, you'll just measure in centimeters. It says that, but we'll stress it, centimeters. So you just write at trial 0, like 10 and 7. And then you would dip your water in one, dump it into the other, and then come back the other way. And then you'd rewrite your new ones like 9.8, 7.2, and you would just keep going until they stay the same number, like 1, 1, 1, 1, 1, 1, or something like that. That, when they don't change, that's equilibrium. Now, one important thing here. All right, you will follow the instructions in the data table. I'll show you that right now. So what it means by that is right here. So in part A, you'll start with more water in the reactants can. So this number should be bigger. And up here, I wouldn't go much past 12. And the small number, I wouldn't go below 6 or 7. 5, whatever, but kind of keep within 5 or 6, 7-ish of each one. All right. And then it says use the 250 milliliter beaker for the forward. So that is reactants to products. And then the 150, so that's the smaller one, for the reverse, and that would be your products towards reactants. All right. Now, there are 3 of these. You can see Part A, Part B, Part C in your lab book. For Part B, do not start where Part A ended, or nothing happens. You need to start with different heights of water. All right. When you are done, you're going to take these numbers, like 12, 15, 12.2, 15, whatever, and then you're going to graph them. I thought I had this, but I guess I don't. All right, there we go. So on this graph, you're going to have 2 lines. So I'm going to say your reactants is red. And you can use my colored pencils. I'll put those right now. They'll just be over here on the iPad card. And then I'm going to say like products is blue. What you're going to do, you're going to have trial number on the bottom. And then you're going to have the height of these two things plotted here. And it's not going to look like this, but let's pretend it looks like that. And then this one looks like this. Anyway, you would have two lines on each graph to represent the height of your products and your reactants. All right, so that's what you're going to do in the lab. Let's come over and just look real fast about what I mean by water transfers. Okay, so in each one, you'll save yourself some time if you put a ruler in and once again measure in centimeters. I've already filled it up where I have more water in my reactants can and less. So I'm about here and here. It says to use the large beaker. That's the 250 for the forward. So forward is where I fill this up as much as I can and I dump it over here. Now, the instructions, I forgot, they were in all caps. It says you cannot tip the cans. Now, you are allowed to tip the beaker all you want and get as much as you can. But you are not allowed to just take the can and tip it over to fill up your beaker. The cans must remain flat the entire time. Okay, so I already did one. It won't matter because whatever. But I'm going to fill it up as much as I can get. Pour it over there. That's the forward. Then I take the smaller one for the reverse because that's what the instructions tell me to. And I dump it back over. And then I remeasure in centimeters and write that in my data table. Then I repeat that. I take the large, 250 for the forward, the 150 for the reverse. I dump it over there, and I remeasure. Then I record that height in my data table. Then I do it again. And this is about the time people get frustrated and think this will never work. But it will. I take the big one forward, the little one reverse, and I remeasure. Once I remeasure, I write that down in my data table. Eventually, I will reach equilibrium. Equilibrium, once again, will be when there is no change in height in the water in either can for 5 consecutive water transfers. So if the water's here, and it doesn't change for 5 of these transfers, then I'm at equilibrium. Please remember, for the 10th time, it does not mean that the water levels are equal. It means the water levels are not changing. All right, remember when you are done with part A, start part B with a different height than you ended part A with, and then just keep going. The instructions for what goes forward and reverse is right there in your data tables. Once you're done, just take these out. You can leave the cans and everything at your stations, but dump them out. And then wipe up any mess you make. Hopefully this activity will clean my lab tables pretty good. All right, once again, when you are done, graph your data and try and answer those questions. Thank you for hard work. And go ahead. There's no safety concerns, no safety glasses or aprons. Just be careful with the beakers, and if any glass breaks, let Mr. Goddard know. Thanks, guys.